Hello, sir. Today we want to explain the project, what you coded for you, because we have some explanation and project specification for that. The first thing it is to start with the project specification for the paper. We agreed that project specification in the start of the project. The first thing, the title is hybrid optimization between the BPSO and GWO to optimal reconfiguration of network IEEE 33 and IEEE 69. So the hybrid optimization between the PSO and GWO, PSO particle swarm optimization, binary, and the GO gray wolf optimization. The network test network, it is 33 and 69 optimization, hybrid optimization. The optimization variables is to the switch line status, on or off. On mean that 1, off it is 0. That mean open that line or close that line to connect the path. The object function to minimize the losses, stability indicators, and the cost also. The constraint that we take into account, voltage limits plus minus 5%, limit line limits, the total number of meshes, and the total number of branches, because we need to remain the same number of line and branches for the original networks. The parameter that we use it in our code, unity load profile, real and reactive power. That mean unity, that mean the per unit, the per unit of the load profile for the reactive and real power for 24 hours, and your reference paper, it is mentioned there, then reflected on that per unit values to the base load of the system for IEEE 33 or IEEE 69. The second thing, it is the integration of renewables. The integration of renewables, we define the PV. The capacity of the PV, it is 760 kilowatt from the reference sensor version 2, and also for IEEE 69 plus 263 kilowatt reference paper sensor, and the location the same paper also. The location of the PV, it is 11 and 16 respectively. And after that we also defined the cost of PV to be $0.139 per kilowatt from the same reference paper, and the profile, the PV profile for 24 hours. That means the per unit PV profile in the figure reference paper. The third parameter that we also put it in our optimization code, it is distributed generator. We will assume 2 generator from your reference paper, and the location of 2, it is different from 2 networks or 2 systems. 14 and 31 reference paper, and the same thing for 69 network, 61 and 63 from the reference paper. And the distributed generation profile, it is considered as a fixed, and the cost also from your reference paper. EV, also we also define the EV, electric vehicles load profile for EV, per unit load profile from website, reference website, and also the number of EVs we consider 25 from the reference EV reference paper. The location of each 8, it is assumed that to be 2, 9, 19, 25 in the IEEE 33, and in IEEE 69 to 28 and 47 from the reference paper. EV rating, also we take the Tesla X Model X 13 kilowatt, the reference paper EV reference, and the cost of the grid, it is also from your reference paper. In our this is the parameter that we considered in our code to be put it as an input. And after that we make two scenarios. The first scenario, it is the base case scenarios without any reconfiguration in the original network configuration. And the second scenario, it is the optimized scenario, that now we need to optimize the reconfiguration or configuration of the system. And after that we printed the results, some result: power losses, voltage profile, total system cost, load profile, PV profile, distributed generator for 24-hour, and EV profile, renewable energy and stability indicators. This is the specification explanation. And now after that, in the second video, we go to the code, the base case scenario, to explain how it is work. Thank you very much.